Hey guys, welcome to Spindle Feeds. It's great you stopped by because we have a really informative episode to share. Now, in our last video, there was an issue with the Bridgeport mill while we were simply drilling a hole in a bushing. While operating the variable speed selector, something in the speed control just snapped. I opened up the front of the head to find the chain that controls the speed change tilt plate became disassociated with its connecting pin. Well, upon further inspection, it was discovered that the chain link used to connect the chain to said pin was nothing more than a construction staple, whose remains were found scattered throughout the head. There's no way to reconnect the chain without removing the motor and the top cover, so that's what we're going to do today. But wait, there's more. I've suspected for a while that the bearings in the motor are on their last legs, so while we have it out and accessible, we're going to address that as well. So let's jump right into it. First things first, we need to remove the bottom pulley cover. There are 3 1024 screws keeping this cover on. Typically you'd use 2 of these rather short screws to compress a spring on the motor pulley shaft. This keeps the pulley hub separated, so it's easier to remove the motor and not fight the belt so much. Since I had no way to pre-compress the spring by adjusting the variable speed, I instead opted to substitute longer screws for this task. Alright, let's unplug the power cord and then we'll set up a work platform. I think it'd be wise to just get this electrical box stripped off here first thing. That was probably one of my least favorite tasks. Next we'll need to remove this top spindle pulley cover. Once these screws are pulled, they can be used in the neighboring holes to jack the plate up. Just got to remember to mark the holes that face the front. Just a little bit of pry bar action. Just under the top plate is a wavy washer. We'll set that aside. Now we can pull this top plate bearing. Alright, so just to get more things out of the way, let's go ahead and remove the motor. The motor is just held on with a couple bolts. Alright, so now we should be able to just tip the motor back, find a good place to get a hold of it, and yank it out of there. Okay, so you see inside this hole? These screws connect the speed adjustment tilt plate to the upper pulley bearing hub. When the plate is tilted up or down using the variable speed adjuster, it pulls the pulley up or lets it slide back down, which changes the diameter and thus the gear ratio of the belt drive. And that's how the variable speed works. Okay, got that disconnected, so let's remove the top cover. In a lot of heads, the sections are pinned, and that can make it a little difficult to remove. Alright, so I guess we just need to pull off this drive belt. Let's check out the bearings in this motor. Wow, would you listen to that? No wonder this thing is running so loud. Pulling this motor apart is a chore. I fought it for a while before realizing that it's just best to strap it down to keep it under control and prevent it from rolling off the bench. Now look, electrician droppings. Now, it's important to be very careful with this stator. It's an expensive mistake for this to fall on the floor. Yank out the rotor and pull the bottom bearing cap. Yep, see, these bearings need to be changed. I could probably remove these bearings in the press, but this bearing puller seems about as easy. I'll use a smaller pulley for the top bearing. And voila! In this package is a new motor bearing set and a replacement top cap bearing, plus a new wavy washer. But I'm curious what the rest of the bearings look like. Okay, well, I'm going to take this to the press and get these bearings seated off camera. Be right back. Pretty much reversed the order in putting this motor back together. So after seeing the state of the motor bearings, the top cap bearing, and further investigating the integrity of the front spindle hub bearing, I decided to order a top-end refresh kit. Now this kit includes new pulley bushings, a new pulley hub bearing, and a new drive belt. I need a way to remove this compression spring, so I'll make use of a piece of all thread to retain the compression to be able to remove the two screws without turning the pulley into a launch pad. Okay, so what I'm fishing around for here is the old plastic bushings. There are two bushings in each pulley, and were set in epoxy when last installed. In order to install the replacement bushings, you'll need to grind or sand out the old residual epoxy. It's important to get it all, and to scrape any residuals out of the keyway and the internal grooves. A Dremel really is the best tool to clean up the bore. It's important to be careful though, as you really don't want to remove the base metal, only the epoxy. The replacement bushing kit comes with epoxy, a coating stick, sandpaper, and steel spacer bushings. You can pause the video if you have the burning desire to read these directions. Before installation, I'll need to take the sandpaper and scuff up the OD of these plastic bushings. Now we apply a consistent coat of epoxy to the hub ID and the OD of the bushing. Once the bushings are installed, you'll want to double check that the keyways are lined up. Then you slide the metal spacer bushing down into the bore. You'll want to give the epoxy 24 hours to set and cure prior to removing these steel bushings. This is the front spindle pulley hub. Now just listen to the bearings in this thing. I'll pop this hub off with a couple pry bars. After that, I'll punch this bearing out off camera. So it's pretty much the same routine to change the bushings in this front pulley hub as it was the rear. Alright guys, well we're about to run out of time for this episode, but there is a lot more we need to do with this head. And I feel like I'd leave you hanging off a cliff if I don't at least show you how much quieter the motor is now. So let's peek ahead at part 2, and until next time, thanks for watching.